Hello, AP Calculus students. This is my video on integrals and Riemann sums. So we actually did integrals in the last packet when dealing with position, velocity, and acceleration functions, but here we deal more directly with them. But starting off, sorry, this is my Unit 6 packet, by the way. Starting off, we are doing something with Riemann sums. Now, dealing with Riemann sums is pretty straightforward at the beginning, right? You're simply doing a bunch of area formulas with rectangles. So let's say they ask in this first question, using a right Riemann sum, using these subintervals. So from 2 to 5, 5 to 10, and 10 to 14. That means I'm using 3 rectangles. So my equation is going to be base height plus base height plus base height. Now, we just have to fill in what the base and heights are, and it depends on the problem that they give us. Right? In this case, let's see, my first rectangle goes from 2 to 5. So my base is going to be from 2 to 5, which means my base is going to be 3. Right, the base of my rectangle. You can imagine a rectangle is being drawn like this. Right, so first I go from 2 to 5. Next rectangle, I go from 5 to 10. So my base is going to be 5. And I'm going to fill these out first. Then I go from 10 to 14. So my base is going to be 4. All right, now the question is on the heights. And the heights can be a little bit tricky. Here we have to actually look at specifically what sort of Riemann sum we're asked for, because from 2 to 5, you'll notice from 2 to 5, I have 2 heights, because at 2, my y value is 12, and at 5, my y value is 28. So which one is it? Which one do I use for my height? Well, specifically, it says I'm using a right Riemann sum, which means when my first rectangle goes from 2 to 5, I want to use the white one on the right. So I'm going to focus for this interval on the 5 and focus on the y value at 5. So it's going to be 3 times the y value 5, so 3 times 28. Next, for my next interval, which I do from 5 to 10, at 10, my y value is 34. The final interval, I go from 10 to 14. My right Riemann sum is 14, so I'm going to use the y value of 30 for my height. All right, you can already see this adds up to 374. Ideally, you would solve this by hand, but that means my answer choice is going to be D, 374. All right, next question. I'm going to keep my Riemann sums equation because it's probably going to be a Riemann sums question. All right, the data for the acceleration a of t of a car from 0 to 6 seconds is given in the table above. If the velocity at t equals 0 is 11 feet per second, the approximate value of the velocity at t equals 6, computed using a left-hand Riemann sum with 3 subintervals of equal length, is what? Okay, so this might be sort of confusing because they're asking me to calculate for velocity, yet they give me a table for acceleration. Well, let's think about what we're actually doing. We are doing a Riemann sum for acceleration, which is really, if you take a look at our notes here, we were just drawing rectangles for area. So we're just calculating area, which means we're basically estimating an integral, which means if I'm doing a Riemann sum for acceleration, that means I'm integrating acceleration. So really, I'm looking at velocity. Right. Okay, so let's calculate for the velocity. Right. The velocity starts off at 11 feet per second. So I actually am starting off, my velocity starts off at 11. Then what I'm going to do is use my Riemann sum to integrate my acceleration from 0 to 6. This will give me my final velocity. So let's expand this. By integrating from 0 to 6, what I'm really doing is doing a left-handed Riemann sum because that's specifically what they want me to do. So let me just erase this and type in base height plus base height plus base height because they asked for 3 rectangles, 3 subintervals to estimate this. So 11 plus base height plus base height plus base height. Okay, let's look at this first rectangle. I go from 0 to 2, so my base is 2. Second rectangle, I go from 2 to 4, so my base is also 2. And the last one, I go from 4 to 6, so my base is always 2. So base for all 3 of these rectangles is 2. All right, then I'm going to look at the height for the first rectangle. Well, from 0 to 2, which height do I use? I use the one on the left-hand side, so I'm going to use 5. So it's 2 times 5. Second interval from 2 to 4, I use the one on the left-hand side. So on this interval from 2 to 4, I use the left-hand height, so it's going to be 2. Finally, from 4 to 6, I use the one on the left-hand side. So I'm going to use 8. All right, and you might calculate your integral and get 30. But don't forget, you have a starting velocity of 11. So you already start going at a speed of, or a velocity of 11, right? So you already start at 11. So your actual final velocity is going to be 41 feet per second. So your answer choice is going to be E. So hopefully that makes sense. All right, next question. A table of values for a continuous function f is shown above. If 4 equal subintervals are used, which of the following is a trapezoidal approximation for 0 to 2 of f of x? Okay, so one note here, this is no longer a Riemann sums, right? Riemann means rectangles. What do they say here? They specifically say trapezoidal sum. All right, so what's my equation for a trapezoid? Well, we learned that equation. We wrote it maybe 1 or 2 different ways, but the way I'm going to write it here is c plus d over 2 times the base. You may have remembered it as a plus b over 2 times h. These are the same equation, I'm just using different letters. All right, and then we said how many of these rectangles were there? Well, there were 3 of them. Right, 3 of these rectangles. Oh, sorry, 4 of them. All right, so I just have to fill in these 4 rectangles. All right, the first rectangle, or the first trapezoid, sorry, the first trapezoid is going to go from 0 to 0.5. The second one goes from 0.5 to 1, then to 1.5 to 2.0. Okay, so that's 4 of them. Perfect. Okay, so what exactly is happening here? Well, remember, b is the base, so let's fill in the base for each of those because that's familiar to us, right? 0 to 0.5, so my base is 0.5. This was easy for us. We did the same thing in the Riemann sums. My second rectangle goes from 0.5 to 1, that's another 0.5. Then from 1 to 1.5, that's another 0.5. Then 1.5 to 2, that's another 0.5. So all of these have a base of 0.5. Okay. Hopefully that starting off makes sense. Cool. Now for each of these, I just need to fill in my C and D. So what are my C and D? I'm actually going to write that here. Trapezoidal sums. Trapezoidal sum uses both heights of the function, which is different from Riemann sums. Remember, for Riemann sums, you only use the right or left or midpoint, right? For trapezoidal sums, you use both the heights. So C and D represent both my heights. So from 0 to 0.5, I'm going to use both this 3 and my right-hand 3. So it's going to be 3 plus 3. All right. Then from 0.5 to 1.0, I'm going to use both 3 as my left-hand height and 5 as my right-hand height. So it's 3 plus 5. All right, when I keep on going then, next one would be 5 and 8. So 5 and 8. Final trapezoid has heights of 8 on the left side and 13 on the right side. So 8 and 13. This should give me my answer choice of 12. So my answer is going to be B. All right, hopefully that makes sense. All right. Next question. The expression here is a Riemann sum approximation for what? Okay, well, let's think about how they wrote this expression. Notice, the first thing I notice is that they took this on the outside, right? So let's say my Riemann sum expression, generally, again, my expression is always going to follow base height plus base height plus base height plus base height plus base height, etc., right? Because I don't know how many rectangles we're going to add. Here, though, they factored out 1 over 50, and they said this is my Riemann sum expression. Well, what can I usually factor out of this? What is the same between the base height? What can I factor out? Well, usually B is the same, right? Usually in our equations, the base is the same for each of the rectangles. You'll notice when we drew our notes here, right? Although each rectangle had a different height, right? Each one had a different height. So I am not drawing this well, but you'll notice each base had a base of 2. 1 to 3, 3 to 5, 5 to 7. So the base is always the same. Not always the same, but usually the same, so I can factor it out. So I'm going to rewrite this equation with the base factor out. So it's really B times H plus H plus H plus H plus H plus ... Right, so I just factored out the base from each, so I'm left with just the heights. Okay, so I can reasonably assume 1 over 50 is the base. Square root of 1 over 50 would be the first height. The square root of 2 over 50 would be the second height. Square root of 3 over 50 would be the third height. Square root of 50 over 50 would be the 50th height. Okay, so what are they approximating here? Well, if I know each of my x values, so at x1, it's 1 over 50. At x2, it's 2 over 50. So looks like I'm going to be looking for something that reflects that. So I see each of my integrals goes from 0 to 1, 0 to 1, 0 to 1, 0 to 1. One goes from 0 to 50, right? All right, so first of all, the one that goes from 0 to 50, if I'm estimating this as a Riemann sum, I would go from 0 to 1. So my x value would just be 1. So my height would just be square root of 1 when I plug it in, right? But here I have square root of 1 over 50. So it's not going to be E, because when I plug in my x values, that doesn't make sense. So you want to figure out which one of these makes sense when you plug in your x values. And if you think about it, right, from 0 to 1, if I'm dividing this into 50 different rectangles, well, my x values are actually going to be, I'm going from 0 to 1, so each x value is 1 over 50, then I go to 2 over 50, then 3 over 50, until I eventually reach 1, right? So I'm directly plugging in 1 over 50. That's my entire x value. 2 over 50, 3 over 50. These are all my x values. So which one allows me to do that? Well, not C, because when I plug in 1 over 50, I would get divided by 50. I'd get 1 over 50 squared. That's not what I'm looking for. So it's not C. It's not A. It's either B or D. Well, D, the 1 over 50, that's actually an average value formula. Like, there's no reason for me to do this. My answer choice is going to be B. If I were to calculate B, right, in this form, each base, like I said, each base is 1 over 50. Each height is gathered by plugging 1 over 50, or my x value, into the square root, in for x. So instead of square root of x, it's square root of 1 over 50. Right, each base is 1 over 50. The next height would be measured by plugging in the next interval, so 2 over 50. This structure matches up exactly with my integral right here after I factor out the 1 over 50. So 1 over 50, each height is the square root, etc., etc. You can see how this expression for this integral matches with this. All right. Okay, we're going to move on now to the next section. All right, first question asks, which of the following is true? Okay, so the notes here are regarding the fundamental theorem of calculus, which basically says derivatives and integrals are opposites. Right? There's a few ways to represent this. First, d over dx of the integral from 0 to x, f of x, or f of t dt is simply equal to, if I take the derivative of an integral, I'm left with just the function f of x. All right. With this question here, they're telling me that h of x is equal to the integral of f of t, exactly how I wrote it here, right? So h of x is equal to the integral of f, and they give us f in this function right there. Right? So which one of the following is true? Well, they're asking me to order h of 6, h prime of 6, and h double prime of 6. Well, h of 6, if I were to plug that into my function, is simply the integral from 0 to 6 of my function f, right? Because I'm plugging in 6 for x. Let's think about what they ask for when they ask for h prime of 6 now, h prime of 6. Well, remember what I said. What is the derivative of h? So the derivative of my integral? Well, the derivative of my integral would just be the original function. So h prime of 6 is really just f of 6, right? Because I am taking the derivative of this, which means I'm canceling out this integral, so I'm left with just f. All right, if I were to take the derivative again, so the second derivative of h, that means I am taking another derivative of f, so I'm looking at f prime of 6. All right, so we have to order these basically. Okay, what is the integral from 0 to 6 of f? Well, my integral from 0, this is 0, to 6, I don't know exactly what this area is, but I do know it's very negative, because notice this integral, I'm accumulating like entirely negative area, so I'm going to say negative. All right. F of 6. H prime of 6 is f of 6, right? What is f of 6? Well, I go to the graph of f, I go to 6, and I notice that it's simply 0. Right? I just go to where it is drawn here, and it's drawn at y equals 0. All right. Finally, f prime of 6. I'm looking at the graph of f now, and I go to 6, but now I'm looking at the slope at 6 because I'm asking for the derivative. So the slope at 6, I will note, is positive. Right. So the proper way to order this is first, the integral should be the smallest. Then the second smallest, which is 0, is h prime of 6. And the largest is when I take the second derivative, because that gives me the first derivative of f, and the first derivative of f happens to be positive because of the positive slope. So it's h of 6, then h prime of 6, and h double prime of 6. Which of this do I see here? Not this one, not this one. Should be answer choice A. All right, hopefully that makes sense. Cool. Hello, hello. We're now going to move on to the next problem, which also asks us to relate derivatives and integrals conceptually. relate derivatives and integrals conceptually. All right, so what information do they give us here? They give us that this is the graph of f, right? And they also tell us that f of x is equal to the integral of g of x, right? So that's an important relationship because then they ask us which of the following, or which is the graph of g of x. Okay, so my first thought is this. Well, how do I get to just g of x? Because I'm given f of x, but I want to find just g of x. And g of x is kind of impacted by this integral here. Well, for me, if I want to get rid of this integral, I'm going to take the derivative, right? So what I can do is I can take this equation, and I'm going to take the derivative of both sides. So f prime of x. This allows me to get rid of this integral. So for me to get g of x, I know g of x is equal to f prime of x. All right, so what do I know about f prime of x? Well, right, so I'll say g of x is f prime of x. So that means g of x is simply the slope of f of x. All right, cool. So that helps me get to my answer, right? Because I'm given the graph of f. What do I notice about the slope? If you think about it, the slope here, the slope is positive. All right, so the slope of my function is positive, which means g of x is positive. All right, so which of these graphs is going to be positive? Well, okay, it's definitely not B. D is negative at some point. There's no reason for it to be negative, so it's not D. E also goes negative. There's no reason for it to be E. So it's either A or C. And the question now is which one? Is it A or is it C? Well, I would start thinking about this. Clearly A is saying g of x doesn't change, right? It's this flat horizontal line, whereas C is saying that g of x changes. It changes like this, right? Changes, it's going up. Well, I'm going to think about this. The slope of f of x is positive, and does the slope change? I would say not quite, right? This function is a linear function. The slope also doesn't change. Remember, this is about the graph of f prime of x, which g of x is. So g of x also, so I'm going to write that here, g of x also is positive and also doesn't change, right? Because that's how they are related. G of x is simply f prime of x. So I would say, which of these graphs is positive and also does not change? It's going to be A, only A. Right? Hopefully that reasoning and that relationship between the derivative and integral makes sense. All right, next question. At what value of x does the absolute minimum of f occur? All right. The function f is defined on the closed interval. The graph of the derivative f, that should say f prime, and it does, it's just hard to see. The graph of its derivative f prime is shown above, so this is f prime. All right, so the absolute minimum of f. Well, again, let's think about this way. I'm given f prime. How do I get to f? Well, I'm undoing a derivative, so that means f is simply the integral of f prime. Right? F is simply the integral of f prime. Conceptually, that's all it is. So here, they asked me to find the absolute minimum of f. So I'm really looking at the integral of f prime. And what does this mean? Well, how do I find the minimum using my graph of f prime? Well, I'm going to be looking at the integral of it, which means I'm looking at the area of f prime. And I'm looking for when the area, so I'll actually write that here. When is the area of f prime at an absolute minimum, right? Well, let's think about that. So if I'm accumulating area, right, remember to calculate for the integral of f prime, I'm simply shading in this area. This is all, notice I'm accumulating positive area. So accumulating positive area, which means it's probably not my absolute minimum. I'm going to say not the absolute minimum because I'm accumulating positive area. My number's getting bigger. How can it be a minimum, right? I want to find the smallest possible value. All right, so I would say it's not going to be between 1 and 6. However, thankfully, at starting from 6 to 8, at 8, ending at 8, I have accumulated some negative area. This seems like the smallest the integral will ever go, right? So the answer seems like 8, right? Because by the time I get to 8, I will have thought, okay, I've accumulated some negative area. This is the smallest my integral will ever go. However, notice one of my answer choices options is 0. So think about it this way. Sure, I've accumulated some negative area, but in total, from what I drew, there is more positive area than negative area, right? So my integral in total is still positive, right? But what happens if I stop at 0? As in, I just don't accumulate any area. I tell my integral to just cut it off right at the beginning. That's actually going to be the right answer, right? Because in that case, I have accumulated 0 positive area and 0 negative area. Actually, I shouldn't emphasize that. 0 positive area and 0 negative area. So my integral is is 0, right? So whereas when I stop at 8, my integral is positive, or if I stop actually anywhere here, if I just stop my integral is positive, right? Well, if I just stop my integral at 0, that's the absolute minimum it's going to be. The absolute minimum the integral can ever be is 0, right? Hopefully that makes sense. So my answer choice is A, 0. Right. The flow of oil in barrels per hour through a pipeline on July 9th is given by the graph shown above. Of the following, which approximates the total number of barrels of oil that passed through the pipeline that day? Okay, well, let's think about it this way. The graph gives us the flow of oil in barrels per hour. So I'm going to say rate of oil flow, barrels per hour. Okay, the total number of oil, we calculate the total number of oil, which would just be barrels. I just want the total number of barrels. I want to figure this out. Well, how do I go from a rate back to just the original function where I don't care about the rate, I just care about the total number of barrels? We are going to integrate. So I'm going to say the barrels is equal to the integral of my barrels per hour function, right? That's the same as my OG function, which I sometimes use to label in class, is the integral of my rate function, right? AKA my original function is the integral of my derivative. So I'm going to say f of x is the integral of my derivative. All right, so hopefully that makes sense. So let's just integrate my barrels per hour function. Well, if I were to integrate this, I'm calculating for the area, which means calculate for the area. under the curve. Okay, so let's calculate for this area. So first, I'm going to calculate just for like this rectangle here. Right, so that is 24 hours. So 24 times, and how many barrels of oil per hour? Times 100 times 100. Right, so 24 times 100, I calculated for this. Then I need to calculate for this, and I'm going to approximate this using a triangle because they ask us to approximate. And this looks like a triangle to me. A triangle has an area of 1/2 base times height. The base here goes from 6 to 18, so there's a base of 12. And a height here of from 100 to 200, so it's a height of 100. If you see here, this equates to 3,000, so approximately, when I integrate, I have 3,000 total barrels of oil that day. All right, hopefully that makes sense. Next question, if f has two continuous derivatives on 5 to 10, then the integral from 5 to 10 of the second derivative is what? This one should be a fairly easy one. So integral from 5 to 10 of the second derivative is equal to what? Well, what is the integral of the second derivative? Well, remember, integrals undo a derivative. So I'm back to the first derivative. Right, and remember, I have to plug in, since this is a definite integral, I plug in 10, and I subtract, and I plug in 5. So I'm going to actually write this out. I plug in 10, then I subtract, and I plug in 5 as well into the first derivative. Just the first derivative, because remember, I did an integral. So that should be my answer choice, and that matches up with C right here. All right, next question. The graph of f prime, so this is f prime. The derivative of f is the line shown in the figure above. If f of 0 is equal to 5, then f of 1 is equal to what? Okay, so f of 0 is equal to 5, f of 1 is equal to what? Okay, so I'm given the first derivative. I want to go back. These are all the original functions. So let's integrate my derivative. All right, so I'm integrating my derivative, and that would give me my original function. However, notice they mentioned specific values, 0 and 1. Well, how do I plug in 0 and 1? I'm just not going to plug those into my derivatives of 0 and 1, because that would give me f of 1 minus f of 0. Right? Hopefully that makes sense. Right? It's a definite integral. I would plug in 1 and 0. And what do they say? They say f of 0 is 5. So it's f of 1 minus 5. All right. Well, actually, I'm going to include an in-between step here. Okay, f of 1 minus f of 0. Well, what is that equal to? I know it's going to be equal to f of 1 minus 5, but I also have a graph here. And remember, I can calculate for my integral from 0 to 1. I can calculate for this, right? It's simply if I shade in this area. So that is the area of a triangle. So to calculate that, it's 1/2 base height. My base is 1 here. And you can see it's 1, so I'm integrating from 0 to 1. My height here is actually 6, so it's times 6. Which means my integral, the integral from 0 to 1, is equal to 1/2 times 1 times 6, which is going to be equal to 3. And that's also equal to f of 1 minus f of 0. F of 0, they said, is 5. So I'm going to add 5 to both sides. So 5 plus 3 is equal to f of 1. So f of 1 is equal to 8. Right, 8. That might be actually sort of a complicated way to think about it. Let's think about it this way. If f of 0 is 5, right? And I know to get to f of 1, remember, this is the integral of f prime of x, right? Well, f of 0 is 5, so I'm starting with 5. Then to get to 1, I just need to calculate for this area, right? Because I'm integrating. And we said the area is 3, right? So I'm starting with f of 0, 5. I calculate the area it takes to get to 1. Therefore, f of 1 is going to be equal to 8. All right, hopefully that makes sense. Excellent. Next problem. This is just based off the answer choices, clearly going to be a calculator problem. Right. So if h of x is equal to the integral of g of t, and g of t is equal to the integral of t squared square root of 1 plus u squared over u du, find h double prime of 2.5. All right, so I'm going to start with this because that's what I'm trying to find. All right, so h double prime of 2.5. Well, first, what is h? H of x is given here, integral from 1 to x of g of t dt. All right, I need to take two integrals, so let's go step by step. First, sorry, take two derivatives, so let's go step by step. First derivative, the derivative of h, well, h is this. When I take the derivative of this, that means I get rid of my integral, so it's just going to be g of x. So h prime of x is equal to g prime of x. Okay, pretty straightforward. All right, what's h double prime then? Well, h double prime is going to be the derivative of g. And do I actually know the derivative of g? Well, remember, we're given two equations. G of my g function is the integral of this other thing, 0 to t squared of 1 over square root of 1 plus u squared. And don't be intimidated by the u. You can use any variables, and this one they chose to use u. Doesn't mean I have to do a u substitution. It's just can be a letter to choose. All right. So g prime of x is actually the derivative of g, which means I can get rid of this integral. Well, to get rid of this integral, right, I would take my function and I'm going to plug in, just take everything and replace it with my top t squared. So it's actually going to be t squared that whole thing is squared all over t squared. So I replaced all my u's with t squared. And then if you remember our notes way back here, when I take the derivative, which is what we're doing, of an integral, and there's an actual function up here. So this should have been in your notes in class. There's an actual function up here. Well, first you replace this variable t with the function, so f of g of x, which we just did, right? I replaced my letter u with my function t squared. Cool. Then I have to multiply by the derivative g prime of x. So it's basically a chain rule, right? So here I need to multiply. I replaced in t squared. I also need to multiply by the derivative of t squared, so I'm going to multiply by 2t. All right, so here's my actual function. Now I just have to plug in 2.5, right? I just got to plug in 2.5. All right. At this point, you could use a calculator to type this out. I typed it out right there. Here, I'm actually also going to just type it on a calculator just so I can show that. All right, and I'll take it step by step. So let's see, first I'm going to do the square root part because that looks like the most annoying. So second square root of 1 plus 2.5 squared. I square that again, divided by 2.5 squared, cool, times 2, cool, then I multiply by 2.5 again. I get 5.063 5, so 5.064, that matches up with answer choice D. Right, you could obviously type it in all at once. I type this first, divided by this, then multiply that by this, doesn't actually matter. Right, hopefully that makes sense. Next question. The graph of f prime, the derivative of the function f, is shown above. If f of 0 equals 0, which of the following must be true? Okay, so similar sort of question that we've done. This is my derivative f prime of x. I'm given f of 0 is equal to 0. All right, well, let's think about which of the following. So they asked me about f of 1, f of 2, and f of 3. Okay, let's think about this. So f of 1, I've accumulated positive area. So I'm going to say it's from 0, it's no longer 0, it's positive, right? Because, to be clear, f, this is the integral of f prime of x, right? F prime of x is given to us, so I'm integrating it. I'm calculating for the area to get f of 1. And the area is obviously positive area, so it's positive. F of 2 here, to get to f of 2, notice I've accumulated even more positive area. So I'm going to say it's positive, but I'm going to make it capital. Or I'm going to say actually more positive. Even more positive. Okay, f of 3 here. Notice, okay, it's a tiny bit of negative area. So from more positive, it's not quite, so I'd say it's not as positive as this, slightly less positive. But I think this red area is so small that I didn't take much away. I think I'm still more positive in f of 1. So here's what I'll do. So f of 1 is lowercase positive. F of 2 is uppercase positive because it's super positive. F of 3 is just the p is capitalized. So it's just somewhat positive. So if I were to order them, f of 2 is greater than f of 3, which is greater than f of 1, which is greater than f of 0, which is just 0. So that should be the order of the functions of the areas, right? So let's see, which of the following is true? F of 0 is greater than f of 1. I disagree with that. F of 2 is greater than f of 1. I agree with that. F of 1 is greater than f of 3. I disagree with that. Okay, so I'm going to choose answer choice B2 only. All right, hopefully that makes sense. Next question. The graph of f is given. Capital F of x is the integral of f of t. Is the integral of f of t. Which of the following statements is true? All right, we could just think about this, right? F of x is the integral of f of t. And which is the graph given? The graph given to me here is f of t. All right, well, if I'm integrating this, let's see. Capital F decreases on 1 to 2. Well, from 1 to 2, I would be accumulating positive area, so there's no way I'm decreasing. It's not going to be A. F has a relative minimum at x equals 2. Well, I've accumulated positive area, then I start accumulating negative area. If anything, I am at a maximum, right? Because I just reached my peak of all this positive area, right? Then I start going down my peak. So that's a maximum, not a minimum. That's not going to be B. Right, F decreases on 2 to 4. Okay, from 2 to 4, I'm accumulating all this negative area, which means my integral is getting smaller and smaller. I would say it is decreasing, so I could probably stop here. C is looking like the correct answer. I do decrease on 2 to 4, and we can verify the rest of them. Maximum at 1, not quite, right? I'm asking about the integral of f, right? So integral, not just straight up, oh, there's a maximum there, so it's a maximum. No, these are not the same graph. F of t and f right here, these are not the same. Not the same, right? So there's not a maximum at 1. All right, hopefully that makes sense. Next question, on which interval is h decreasing? Okay, well, let's think about this. H is equal to the integral 0 to 2x e cosine t minus 1 dt. All right, on which interval is h decreasing? Well, that means I'm going to look at h prime of x. And I'm going to look for where h prime of x is negative. Right? Same thing. H is decreasing where h prime of x is negative. Well, let's find h prime of x. Remember, derivative h of x is an integral. To find the derivative of an integral, I basically get rid of the integral, right? So instead of e cosine of t minus 1, it's basically e cosine of t minus 1, but I just replace the t with 2x. Right? One other thing, though, since this is an actual function, I need to do what I talked about before. I need to multiply by derivative of 2x. It's basically a chain rule. So I multiply by the derivative of the inside function, so I multiply by 2. All right, so I want to see where this function is negative. Well, how do I see where it's negative? Well, luckily, you can see this problem here. This is clearly a calculator problem. I'm just going to use my calculator and see where it's negative. So let's take a look here where it's negative. What I'm going to do is I'm going to plot my function. Let's see. So e, second e, cosine of 2x, good, minus 1, end parentheses, times, parentheses 2. I'm going to write it out just like I wrote it there. I'm going to graph this, and I want to see where it's negative. All right, so it looks like it's negative in a lot of spaces, but I'm keen on the interval from 3 to 6. So let's go to 3 to 6. Here you can see the x values. My x values at 2. All right, so from 3 to 6, it looks like it starts right here. So I'm going to zoom in really quick, actually, so I can see closer. All right, I hope this zoomed in on 3 to 6. Good, good. All right, so it would be starting right here. It looks like it starts at 3.93, which is going to be A. To make sure, I can just trace, or sorry, second trace, see where it really goes negative, right? To do that, I see where it hits 0. So that's my left bound. I go to the right of the point where it hits 0. Right bound, my guess is right here. 3.92699. That's when it hits 0. That's when it starts going negative. And that means it's going to be A, right? Starting at 3.927, it starts going negative, which means h prime of x is negative, which means h of x is decreasing. All right, hopefully that makes sense. All right, next question. The acceleration of an object in motion is defined by this. So a of t is equal to square root of 1 plus t squared. The velocity at t equals 6 is 22. Find the velocity at t equals 1. All right. They're saying v of 6 is equal to 22. V of 1 is equal to 1. Or so, right, v of 1 is equal to question mark. All right. First question, how do I get from acceleration to velocity? Well, what I would do is integrate acceleration, right? So I'm going to integral of acceleration. So integral of this square root of 1 plus t squared function, right? That's equal to my velocity. However, I want this v of 6 and v of 1 value in my equation, right? So to do that, I'm going to make this a definite integral. So integral of 6, integral of 1. This definite integral means I would plug in 6 and 1, right? And what do they say? V of 6 is 22 minus v of 1. So my actual equation is this integral is equal to 22 minus 1, which means if I want to get v of 1 by itself, because ultimately I'm trying to solve for v of 1, right? So if I were to isolate v of 1 by myself, v of 1 is equal to 22 minus this integral. So let's just solve for that. Let's do and solve for my integral. Let's go to 22. Yeah, let's do it all together. You could do this separately. You could do this all together. 22 minus. I'm going to then go to my math function. Math. Remember, we can go to fn int to solve my integral. Okay, I go from 1 to 6 of my square root. So it's second square root of 1 plus x squared dx. Enter. 3.653. So that is going to be answer choice B. Okay, hopefully that makes sense. All right, next few problems. All right, so these next few problems are just solving integral problems. I may go through some of these quickly, and I think there's two I would like for us to actually skip. I'm trying to figure out which ones they are right here. I think it was this problem. We can skip it. So I'm just going to give credit for this when you're doing it. And so the last two problems, basically. All right, the other ones, I'm going to go through and solve them quickly. Okay. First one, integral of 1 over e of x squared divided by x. We really don't have many integration methods, right? So actually, let's review my integral methods. So maybe not the quickest. First method is anti-power rule. Right? That's important to know. Second method is derivative identities, which is weird. What do you mean derivative identities? I thought we were doing integrals. Well, remember, integrals are the opposite of derivatives. So I would just do the opposite of derivatives to solve for my integrals. Third one, I guess, is basically algebraic manipulation first. Then anti-power rule, that sort of stuff. So you'll see what I mean in a second. And the fourth method is, so these are all very standard. Like I almost don't want to call them methods because I think you guys know these. The fourth one, we really only have one main one, which is U substitution. Unlike derivatives, which have product rule, quotient rule, etc., we just have one main method for integrals, which is U substitution. All right. So for this integral here, integral of 1e x squared minus 1 divided by x dx. Okay, well, this is the same as the integral of 1 to e of x squared divided by x minus 1 divided by x dx. All right, so hopefully you follow here. I'm just dividing each term by x. Cool. This simplifies x squared divided by x is x. 1 minus x, that can stay the same. I'm going to go to the next line. So I'm going to integrate all of this. Integral of x is x squared over 2. That is an anti-power rule. Minus the integral of 1 over x. Well, here's where I do my derivative identities. 1 over x is the derivative ln of x. So if I were to go backwards and do my integral, this turns back into ln of x. All right, that's my integral. Then remember, I have to plug in e and 1. So first I'm going to plug in e, and I'm going to subtract and then plug in 1. So first I plug in e, so it's going to be e squared minus ln of e minus, and then what do I plug in? I plug in 1 squared minus ln of 1. All right, let's simplify this. Ln of e. Ln of e, remember, ln is base e, right? Base e. You can imagine there's a base there that's e. So ln of e simplifies to 1. Ln of 1, a natural log of anything 1, that's going to be 0, because ln is base e. E to the 0 is equal to 1. So it's 0. All right. So this turns into e squared over 2 minus 1 minus 1 squared over 2, that's just 1/2. So it's really e squared over 2 minus 3/2. 3/2. All right, so that's my final answer, as simple as I can get it, and you can see that matches up with answer choice E. Cool. Next problem. Integral of 1 to 3 f of 2x dx. Well, okay, go back, review your integral methods, but this one, basically, like, obviously, I can't use an identity for this. There's a 2x inside, so I'm going to do a u substitution. We don't really have any other methods. U is equal to 2x, and hopefully you can go through this quickly. Du over dx is equal to 2. That means dx is equal to 2 over du. Right. Cool. So let's rewrite everything in this integral. Right. So it's f of u. And instead of dx, we said dx is, oh, sorry, it should be du over 2. I miswrote that. Dx is du over 2. Cool. I'm going to get rid of the 3 and 1 because those are in terms of x right now. So let's think about that. Those are in terms of x. So I integrate f of u. So now it's capital. So when I integrate lowercase f, it's now capital F, f of u. And it's actually 1/2 f of u, right? Because this du is divided by 2. So it's 1/2 f of u. Cool. I can now go back and replace my u. Right, I integrated, so the next step I can replace everything back in, so my 2x back in. All right, now I'm going to plug in 3 and 1, right, because remember it's a definite integral, so I still need to plug in my 3 and 1. So I plug in 2 times 3 minus 2 times 1. So it's going to be 1/2 f of 6 minus 1/2 f of 2. Does this correlate with anything? Yeah, it looks like it's going to be answer choice E right here. If you made a mistake of plugging in just 3 and 1 directly into this, you might have gotten answer choice B, but that is not correct, right? Because you have to replace your u back in with 2x. That's like the final step of u sub. All right, next problem. This one might look complicated, but I'll show you really quick. I can immediately just rewrite this integral. Instead of 1 over x squared, it's x to the negative 2. This turns into anti-power rule, so it's x to the negative 1 divided by negative 1. Right? Which I can simplify this, right? It's going to be negative 1 over x. Because I move the x to the negative 1 down, the negative 1 just turns it negative. Cool, I'm going to take this negative 1 over x. I'm going to plug in my variables, so 2 minus, remember, another negative 1 over x. So 2, and I'm also going to plug in 1. So it's negative 1/2 plus 1. So that is positive 1/2. And you can see that right there. So my answer choice is going to be C. It's negative 1/2 plus 1. Answer choice C. All right, next question. Similar sort of thing. A lot of these are just algebraic manipulations. So I'll actually type that here so you can understand what I'm doing first. So algebraic manipulation, then anti-power rule. So let's see how that works out here. The integral goes from 0 to 1 of square root of x, x plus 1, dx. All right, let's rewrite this. Square root of x, it's the same as x to the 1/2. I can actually distribute that. I'm going to multiply it out. So x to the 1/2 times x, that is x to the 3/2. x to the 1/2 times 1, that's x to the 1/2. Cool. When I integrate, it's now x to the 5/2 divided by 5/2 plus x to the 3/2 divided by 3/2. And this is my anti-power rule, right? I'm doing my anti-power rule here. All right, when I divide by a fraction, it's the same as multiplying by the reciprocal. So it's 5x to the 5/2 divided by 2 plus 2x to the 3/2 divided by 3. Cool. I now just rewrote that as this. These are the same thing. Then I plug in 1 and 0. So first, I'm going to plug in 1 here, then I subtract and plug in 0. So let's do that. First, I'm going to plug in 1. Not 51, sorry. Just 1. 1 there. And what I say, plug in 0 here. Okay, Desmos should solve this for me, but it's actually easier than I sort of will expect because, well, anything to the 0 power is 0. So this whole thing actually is just 0. Okay, 1 to any power is also just 1. So it's really just 1 here for all of these. So it turns into just 5/2 plus 2/3. And you might be like, which one of these is this? Well, you would have to know how to simplify these into a fraction, I guess. So let's see, what's the greatest common factor or greatest common multiple? Sorry, least common multiple between 2 and 3. I would say 6. All right, so one moment. I realized I sort of made a mistake here. When I divided by 5/2, dividing by the fraction means multiplying by the reciprocal. That means I should have multiplied by 2/5. So all of these should be 2/5. That is my mistake. And that makes a lot more sense for my final answer. Should be 2/5 plus 2/3. The common multiple of this is 15. So 15, 2/5, that is the same as 6/15, plus 2/3 is the same as 10/15. So 6 plus 10, that's 16 divided by 15. My answer choice is going to be C. All right, hopefully that makes sense. All right, next question. If the integral from a to b of f of x dx is equal to a plus 2b, then what is the integral from a to b of f of x plus 5? Okay, well here, let's not panic here. This plus 5 doesn't throw much of a wrench into anything because with any integral, I can just separate it, right? So I can first solve for the integral of f of x dx and just separately solve for my integral of 5. Right? That is entirely allowed. Right? Because anyway, when we do integrals, we do it term by term. So here I'm simply integrating term, the f of x term, then the 5 term. Okay, well, what is this integral of f of x? They said it's a plus 2b. Okay, cool. So a plus 2b, I already solved for this half. I just need to solve for this integral. Integral of 5 from a to b. Well, what is the integral of 5? The integral of 5 is just 5x. Oops, 5x. Then I would plug in b and a, right? So it's 5x, but I plug in b, then I subtract and do the same thing and plug in 5a. Plug in, sorry, a, right? So it's a plus 2b plus 5b minus 5a. All right, so it turns into 7b minus 4a. Answer choice is C. All right, next problem. This one is clearly a U substitution because we have not learned any, I can't do anti-power rule with this. This is not in a derivative identity. So my U is equal to x to the 4th. It's in the exponent. du over dx is equal to 4x cubed. Dx is equal to du divided by 4x cubed. Right, so this derivative allows me to cancel out this x cubed. Right, so my integral is of x cubed. I'm replacing everything. E to the u. Instead of dx, it's dx is equal to this. So dx is equal to du over 4x cubed. All right, that's great because this x cubed and this x cubed here, they cancel out. So x cubed, x cubed. So when I do my u sub, I actually end up with the integral 1/4 integral of e to the u du. Excellent. Well, I can integrate e to the u fairly easily. That's just e to the u. All right, so my integral is 1/4 e to the u. And now I'm going to replace back, full circle, I need to replace back my u with the x's. So it's 1/4 e to the x, or sorry, e to the x to the fourth, right? My u is x to the fourth. Cool. Now I just have to take this and I plug in 1. So first, I plug in 1, then I subtract, then I plug in 0. All right. So 1 to the fourth is just 1, so it's 1/4 e minus e to the 0 is just 1, so it's a minus 1/4. 1/4 e minus 1/4. So I guess that's just, oh, that simplifies to answer choice A right here. All right, hopefully that makes sense. Next problem. All right, so this next problem actually is one I was sort of tempted to skip, so if you don't understand this one at all, I don't think it's too big of a deal. They tell me the integral of f of x minus c is equal to 5. All right, they also tell me c is a constant. So c is some number. You can imagine c being a number like 3, for example. It's just some number. Okay, well, in that case, if this c is just a number, it doesn't actually impact much, right? Basically, if I were to do a u substitution where u is equal to this x minus c, du over dx is equal to just 1, right? So dx is equal to du. So basically, my u substitution doesn't change anything. So essentially what I'm getting at is my integral of f of x minus c, if I were to use capital F as my integral is simply going to be f of capital F of x minus c. So to be clear, my integral from 1 to 2 of f of x minus c, lowercase f of x minus c, I don't have to change much. It's just going to be a capital F of x minus c. I could do a u sub, but it wouldn't change anything because this is a nice derivative. Derivative of x minus c is just 1. Cool. So that's my integral. I'm going to plug in 2 and 1. Oops. Plug in 2. Then I would subtract and then plug in 1. All right, and they said this integral is equal to 5. All right, they give us this other integral. This other integral says it's integral of 2 minus c, so my c's are somehow in the bounds, and 1 minus c of just lowercase f of x d of x. Well, here I really don't have to worry about anything. The integral of lowercase f of x is just going to be capital F of x. It's just sort of a rule. Right, that's the integral. Okay, well, I need to replace this x with my bounds and subtract. So first I plug in 2 minus c, then I subtract, and I plug in 1 minus c. All right, you'll notice these two are the exact same. 2 minus c, 1 minus c. So this is also equal to 5. So both of these are equal to 5, essentially, because they end up being the same exact integral. Right, hopefully that makes sense. All right, next one, integral from 0 to x of sine of t dt. Well, here I'm just integrating sine. So remember the thought process we think of? This is a derivative identities integral, right? And the process we think of is sine of t is the derivative of what? This is that phrase I had us repeat in class. Sine of t is the derivative of what? Well, sine is actually the derivative of negative cosine, which might be sort of tricky to remember, but think about it. Take the derivative of negative cosine. It would then be negative sine, so it'd be positive sine. Sine is the derivative of negative cosine. Therefore, it's going to be negative cosine of t. We'll have to plug in x and 0, so negative cosine of x. I'm going to subtract, right? Then I plug in negative cosine of 0, because I have to plug in my bounds as well. X and 0, I need to plug those in. So it's negative cosine of x minus cosine of 0 is 1, so it's minus negative 1. So it's really negative cosine of x plus 1, which is the same as 1 minus cosine of x. So my answer choice is going to be E. All right. Hopefully, if you're lost on that, you can go back and follow the logic there. Okay. Next question. If f of x is equal to g of x plus 7 for the integral from 3 to 5, then the integral from 3 to 5 of f of x plus g of x is equal to what? Okay. Maybe they make this sound complicated, but it's really deceptively not. All right. So f of x is equal to g of x plus 7, right? So instead of this f of x here, right now, replace it with g of x plus 7. That's my first instinct, at least. Rewrite it there. So g of x plus 7. Cool. I can change this so it's going to be really 2g of x plus 7, right? I'm just simplifying the two g of x's, combining them. All right, remember, with any integral, I can separate the terms. I can just solve for the terms independently. So it's the integral of 2g of x plus integral of 7 dx. All right, one trap answer. Make sure you do not fall for this. A. Do not fall for A, because, yeah, it looks like there's the 2g of x and the 7. However, I can take the 2 out of g of x. However, I cannot take it out of the 7. Right? Or if I did, it would have to say 3.5, which it does not say here. So A is not the right answer. All right. 2g of x dx plus the integral from 3 to 5 of 7. Okay. So here we can solve for this. It looks like for all of these, they do write the 2 out front. So 2g of x, I can write this as 2 out front of g of x. And I need to solve for this separately. Integral from 3 to 5 of 7. Okay, so there's, I guess, two ways you can think about this. First, you could just take the integral of 7. So that's 7x. Right, and I'm going to plug in 5. 7 times 5 minus 7 times 3. That's equal to 14, so plus 14. Another way is, remember, this is just the area of a rectangle, right, with a height of 7. And since I go from 3 to 5, my integral goes from 3 to 5. That means I have a width of 2. So a height of 7, a width of 2, that gets me 14. All right, there you go. So my integral here of g of x is separate. I have not solved for this. My integral of 7, I did solve for this. It is 14. So my answer choice is going to be B. Right, make sure, again, you do not choose A, because you need to integrate the 7. It's still part of your integral. Okay. Next question, right here, I'm going to treat this as a calculator question. So if I were to plot, for example, e to the negative x squared, and I graph this. All right, so clearly I need to zoom into the right spot. Go, go, go. I'm going to go, all right, cool, that should be enough. Cool, I can zoom in again. All right, so I see what looks like a very symmetrical looking graph. So what do they say? My integral from -1 to 1 is k, right? So basically here, I'm going to sort of draw this graph. So it's quite symmetrical. My integral from -1 to 1. So this red part, so this red part is k, right? Well, what's my integral from -1 to just 0? Well, that means I stop right halfway. So I stop right there. Well, it's half of k then, so it's just going to be k over 2. That's it. That's how you solve this one. Instead of it being k, I just stop halfway. I would stop right here, basically. So it's just k over 2. All right, last two, again, I'm going to skip, so I will give credit for these regardless, and that is going to be it for today. All right, for this packet.